about the different centers of a triangle and how you can calculate different parts of different segments formed within a triangle. All right. So the four centers, like I said, are incenter, circumcenter, centroid, and orthocenter. Now, they're created by different segments within the triangle: perpendicular bisectors, angle bisectors, altitudes, and medians. And we're going to talk about what those are. All right. So, let's first look at this graphic organizer, specifically circumcenter. So, we're going to start with circumcenter. Now, circumcenter, it would help if I was unfreezing that. So, circumcenter is going to be created by a specific line segment. If I'm looking back at my GeoGebra, all right, I'm going to click on the circumcenter, and then I'm going to click on all of the different line segments. So medians, perpendicular bisectors, altitudes, and angle bisectors. Which type of bisector or which type of line does the circumcenter always go through? Which ones do you think? So is it the medians? If I move it around, does it always fit in the center of those medians? Yes, no, maybe. What do you guys think? No. What about the altitudes? Does it go through the circumcenter? Nope. What about the angle bisectors? Do they go through the circumcenter? Do the angle bisectors go through the circumcenter? I know it's light, but it's actually no. Then the perpendicular. Do these lines go through the circumcenter? What's up? I didn't see it, but you're welcome to look. So these are formed by the perpendicular bisectors. Now, what do we know of when we hear the word bisectors? What's important about perpendicular bisectors? They do what? They cut through a line or a side evenly. So if we look here, these three lines right here are my perpendicular bisectors. All right. They form at 90-degree angles. That's why they're called perpendicular bisectors. And they also cut these parts of the triangle in half. So they cut the sides of the triangle in half where they intersect. So again, these are the perpendicular bisectors. So I'm just going to do the perpendicular symbol bisectors. Now, here's some special properties about the circumcenter. The circumcenter is equidistant from each vertex of the triangle. Now, what do I mean by the word equidistant? What does it sound like to you? If I split equidistant into two words, what two words could I make? Equal distance. That's exactly what it means. It means it's the same distance or equal distance, however you want to put it. So, what are the vertexes referred to as? So, on these triangles, where will my vertexes be of the triangle? So, my vertexes of the triangle, or vertices of the triangle, what letters are they? Are they A, B, C, or X, Y, Z? A, B, C. So, these points right here are my vertices. So basically where the tip of the angles of each triangle are. That's a vertex. So that means if the incenter, not incenter, if the circumcenter is equidistant from to the vertices, meaning it's the same distance, that means that each one of these lines right here, so if you drew a line directly to the vertice from the circumcenter, they would be completely congruent. They're the exact same length. Now, we also discovered through our discovery activity that the circumcenter is also the center of which circle? Was it the circumcircle or the inscribed circle? What's this circle called that I'm drawing? Even though it's a terrible circle. So what's that circle called? It's a terrible circle, but I try my best. The circumcircle. So another thing to note down here is the center of the circumcircle. It is the circumcenter is always the center of the circumcircle. Meaning, if you were to draw a circle that goes through all three vertices of the triangle, the circumcenter would always be the center regardless of how big or small you make the triangle. Now, what would those red lines up top be if this is always the center of the circle? So if this is always the center of this circle, what would those red lines be? So what property of a circle would those red lines be? They would be its what? So guys, this red line right here would be the circle's what? The radius. So all of these red lines are also the radius of the circumcircle. All right. So that is a circumcenter. Then we have the incenter. Now, the incenter is formed by its angle bisectors. So what do I mean by angle bisectors? It cuts the angles in half. So in other words, it'll cut the three angles of a triangle in half. All right. So, for example, if I'm looking back at my activity, if I'm looking at circumcenter and the angle bisectors, it's really faint, but all three of those go through the incenter. So, important facts here is that the incenter is equidistant. So again, that means equal distance from each side of the triangle. All right. So by that, what I mean is if this is the incenter right here, not only do these lines bisect the angles, so meaning they cut them in half. So that means these two little angles are congruent, these two little angles are congruent, and these two little angles are congruent. So these red lines are angle bisectors. It also means that if you were to draw a line straight from the incenter to the nearest side, that line would be congruent to this one to this side and from this one to this side. It's always going to be equidistant from the sides of the triangle. Now, it's also the center So these go here. It's also the center of the inscribed circle. And again, this is a terrible circle, but I tried. So it's also the center of the inscribed circle. All right. So this is also the center of the inscribed circle. And what's congruent is its radii. So these green lines right here are also the radius of the inscribed circle. So a good way to remember circumcenter and incenter is that whatever lines form their radius, those lines are congruent. So for circumcenter, it's the lines that are formed between the vertices of the triangle and the circumcenter. Those are also the radii of the circumcenter. And for inscribed circles, it is the radii formed by going from the incenter to one of the sides. Those are also the radii of the incenter. All right, and also don't forget that these will also bisect because they're radiuses, and in Unit 6, we'll learn why this is, but a radius always bisects a side or hits a side at a right angle. They're always perpendicular. Now, I'm going to come back to median in just a second, but we're just going to go ahead and do orthocenter next because it's pretty straightforward. But centroid takes a little bit of work. So, orthocenter, all right? This is created by the altitudes of the sides. Now, for those of you who don't know, the altitude is basically if you were to draw a line from the vertice to the side to figure out its height, that's the altitude. So the altitude is the highest or longest line that you can make from one side to its opposite angle. That's what an altitude is. It's also referred to as the height of the triangle, but again, it depends on which part of the triangle you're actually looking at. So, altitudes. So, an altitude is created by a vertex connected to its opposite side so that it is perpendicular to that side. So, in other words, this line would form a right angle from where it starts at its vertex to when it hits its opposite side. It will intersect that side at a right angle. That's what an altitude is. And what's so special about them, besides that the orthocenter is formed by their intersection point, it has no other special properties. There's no like congruency. There's no other formulas that we can get those measurements. The only thing special about an altitude is that it's perpendicular to a side length, meaning it forms a right angle. So nothing special about that, really. Now, centroid is probably one of the more complicated ones. This is the one that a lot of people have trouble with. All right. But it's not too bad. It's just a little bit you got to think about. So, a centroid is formed by the medians. All right. The medians are created by a vertex connected to the midpoint of the opposite side. So, for example, X, Y, and Z in this case are the midpoints of the triangle. All right, these are all midpoints. They make Each of these sides, they cut them in half perfectly, meaning that those points are the midpoints. Now, the line that goes from, say, C to X, that's called a median. All right, so from C to X, that's a median. Now, the lengths of those medians are formed by different aspects of it. So, it talks about the short, the long, and the actual median itself. So, there's a formula to get all of them. All right. So, for example, if I'm looking at one of these medians, so let's just say YA. All right. This orange is considered just the median. The whole line is considered the median. Now, the median can be broken up into two segments from where it hits the centroid. The short segment and the long segment. And typically you can eyeball it. So, what do you think this segment is? The short or the long? Does it look shorter than the other half or longer than the other half of the median? It looks shorter. So this is considered the short segment. And then this part right here is considered the long part of the segment. And the way it works is that you can find the short segment by taking 1/3 of the median. So the length of the median, you essentially just divide it by what? So if I'm multiplying the median by 1/3, that's the same thing as dividing by what? Guys, multiplying by 1/3 is the same as dividing by what? 3. Heads up, guys. Come on. So it's the same thing as dividing by 3. Now, the long segment you can find by 2 times the short. So all you do is just double the short. And the median is 3 times the short. Now, there is a way you can get from medium to long, but you'd have to multiply by like 2/3 or 3/2 or whatever. So I would just find the short and then use the short to find the other two. So the short's kind of the middleman. All right. So again, to find, say, the short, you would just take the median and divide it by 3. Yeah. To find the median, you would take the short and multiply it by 3. And then to find the long, you would just take the short and multiply it by 2. That's all you got to do. And you will be asked those questions. They may give you the median, ask you to find the other two sides. They may give you the short, ask you to find the other two side lengths. All right. So you need to know how to do that. Any questions on the different centers of the triangle? Now, the back side is just another recap of what we just said. So we don't really have to go through any of that. It's already filled in all the way for you. It's just a nice recap. All right. All right. Any questions? So your assignment today is another delta math. Most of it is just you identifying what the center is, as well as finding different properties of it using those properties that we just discussed. Any questions? Also, if you'd like, you can go ahead and take your 5-minute break. When you come back, get started on your work, and I'll go ahead and post the exit ticket too. So I'm not going to start the timer, but be back by 12:50. So it says 12:43, but that clock's a minute slow. 12:50.